Hello, learners. Hope you are keeping well and safe. Remember again to actually follow all the rules of the lockdown. It's the safest thing to do. Today we'll be looking at one of the areas, river capture. This is one of the areas that you mentioned as an area of concern. Yes, it's not the easiest section, so I'll be dealing with this in more detail today. And I will also look at some questions of some past papers, which can assist in terms of the answering of the questions. Now, obviously, again, I'm going to emphasize, as I did in class, the conceptual approach is the way to go. Now, in most cases, we find, or in many cases rather, I wouldn't say most, in many cases, we find learners just learn off content. And that doesn't work in geography. River capture is one of the best sections in which you can apply the conceptual approach, where it's uh, learning out the concept, learning how to apply it to make it more meaningful in terms of various situations, and then eventually applying it to past papers or questions itself. That guarantees you getting a proper understanding of that. Remember, if you write the exams, you don't look at answers, you look at questions. And I always say, if you want to drive a car and I gave you a manual, you only learn the manual, but you don't drive the car well. You need to practice on the car and use the car, and that's how you learn to drive properly. So the conceptual approach deals with that. Let's get on with river capture. All right, I'm going to minimize myself because I'm not the most important person here. And then I'm going to go on to the first slide. Now, whenever you do any section, it's very, very important to look at past knowledge and apply it. Sometimes we are at fault also as educators. We just go on and we mention certain concepts in the process of developing another concept and its understanding, but sometimes we actually don't know. We need to know two important concepts here. And that, if you look at it here, would be let me get my highlighter working, would be the first one will be the watershed. You've done this earlier, so you know that it is a high-lying area separating two river systems or drainage basins. Please note there's a difference between the interfluve and the watershed. The interfluve is actually separating two streams of the same river system. So this is a high-lying area that will separate two complete river systems, like you've got the Drakensberg in South Africa separating the Tugela River and the Vaal River. Okay? Then there's another important concept that you need to know in order to understand river capture, and that's headward erosion. Erosion that happens at the origin or the source of the stream channel or near the source of the stream channel. And as it erodes, it moves backwards or back away from the direction of the flow. All right. If I had to, I know this is a lot of words. If I had to create a channel here, please excuse my drawings, and I had to create a river here, let's create a bit more on that. And I had to create a river flowing here. All right, that's my river flowing. Let me create a little arrow. Okay, and as it flows, it will erode these areas. And if I do that and try and get an eraser, and then I say as it goes, it starts to erode. I think I've taken away most of it, but let me draw that again. I'm also still exploring my stuff. Let me get back to my highlighter, and I want to draw that. Okay? But you get the idea. it will erode into this, and it will erode upstream and carry on eroding upstream. In that way, it's eroding towards the source of the river and away from the direction of flow of the river. It's eroding this way, and the river is flowing that way. Okay? So we do need to know these two concepts in order to look at this. Now, uh, here we will deal with two things. Okay? We will be dealing with river capture and abstraction. And our main focus, if I look at river capture and abstraction, all right? Notice my lines. I hope you don't draw lines like that in map, okay? Because you fail. I'm old. I finished past matric. Okay. Uh, the two main factors that we'll be looking at in these processes is number one, the energy of a river. Uh, in chances, one river will have more energy than the other river. Okay. And this then will allow one river to capture the headwaters of another river. Okay. Of another river. So we're looking at one river having more energy, and we're looking at it capturing the headwaters, the waters nearer to the source of another river. How is this going to happen? This is what makes it interesting. All right. How is one river, due to energy, going to capture the headwaters of another river? Okay. It's like episodes of your favorite show on television. It's exciting. Let's look at the next thing that actually happens. Okay. Now, let's look at why would one river have more energy than another river. Now, in the past, you've also learned if one river flows over a steeper gradient than the other river, it will obviously flow faster because when water flows down a steeper gradient, it flows faster. And if it flows faster, it'll have more energy. All right. Then we look at another one. If one river has less resistant rock over which it flows, the underlying rock is less resistant, meaning softer rock. So what actually happens here? If the other one has more resistant rock, the softer rock will erode faster than the harder rock. Okay. And the last factor here is the volume of water. So that tells us if one river has a greater volume of water than the other river, and if there's more water, it would have more energy, and the greater volume will allow it to erode more. So these processes will create a difference in erosion between two rivers if they are different in these processes. Okay, of course, I had to consult sources, and some of the sources that I used were the following. Okay, let's get started with the processes now. Let's look at the first one, abstraction. Now, in each one, we're going to put in the three processes that I spoke about. It would be a softer rock, steeper gradient, or greater volume of water. And greater volume of water could be due to more rainfall or more tributaries. Various factors would influence this. I'm going to move this face a little bit up so that we have a better view of everything. Okay, now let's look at abstraction. Here, if you visualize, and I would say if you visualize here, and I'm going to get my laser pointer, let's take this as being one of the rivers and this being the other river. Okay, so we have two rivers flowing. Obviously, if I had to look at it, this would be the high-lying area separating the two river systems. So what would this be? This would be my watershed. Okay, the high-lying area. All right, so if I had to look at this and I had to use my pen, I would say watershed. I must get my pen back. All right, pen that I have, and this would be my watershed. I want to get back to my slide. Okay, so I would then go here and talk about a watershed in that area. This I would call river 1, and this I would call river 2. Okay, now let's look at what's happening here. Let's look at one of the factors. Is it gradient? Is it volume? Or is it the soft and hard rock? What's evident in this photograph is that here we have a steeper gradient than in river 1. So this is flowing over a steeper gradient. All right. Now, what's going to happen? We can already make a decision. There's no other factors like soil or rock resistance in terms of underlying rocks, etc. We just have the gradient factor. So obviously, this river is going to have a higher rate of headwood erosion or erosion compared to this river. Now, in abstraction, also what you notice, the rivers are flowing away from the watershed. All right, it's flowing away. The watershed is in the middle, they're flowing away. So let's look at what is happening to the watershed. Number one, this river is eroding more. Okay, so let's put it down here. Again, let's put river 1 down here as it's eroding, and it's eroding greater down here. Let's put it down here. Okay. So what's happening to the watershed? The watershed is decreasing in height and it's moving towards the river with less erosive power. It's moving into that. Can we see that? Okay. As it's moving, because there's more headwood erosion happening in river 2, which is a steeper gradient. Eventually, what happens when the watershed decreases in height and also moves towards or more into the slower flowing river, we find that there's water here. Now the watershed is sitting here, and this water, you understand, gets captured by this river. And that's your process of abstraction. That this water now, because the watershed is here, the headwaters of river 1 gets captured by river 2. Okay? Your process of abstraction. So in summary, it occurs when streams flow on either side of the watershed. I'm going to move this face again down here. Either side of the watershed. Okay? They're flowing away. And if one stream has more energetic or is more energetic than the other, okay, and again, this could be due to 3 factors, as I mentioned. The factors are, again, gradient, volume of water, resistance of rock. Then it will erode upstream. And as I said, the watershed will move in the direction of the less energetic stream. And this allows the more energetic stream to capture, as I mentioned, to capture headwaters of the less energetic stream. Okay, obviously, things like the size of the drainage basin of the more energetic stream, because it's getting bigger now, it's capturing the water, will increase. Okay, so this is your process of river capture. Okay, or sorry, I rather would say abstraction. I want to correct myself there. Abstraction. All right, let's go further. Now, river capture. Again, it involves capturing the water of another river. And when I look at the definition, it says when one more energetic river captures the headwaters of a less energetic river. Okay? A less energetic river. All right. Don't worry about the yellow line here. That was just a mistake, slip of the hand. I'm just kidding. All right. Now, we look at it differently here. The situation in terms of the watershed and the rivers itself, okay, is different from the abstraction. Here, the rivers flow along the watershed. Can you see it? More or less seems like parallel. Along that. This is your watershed. The W I'm saying represents watershed. And there's two rivers here. So at first, there's a stream flowing into this, okay, or tributary, and it seems to be eroding headward, okay, and it's moving into the watershed and cutting into it. Now, there could be reasons again, and it's practically the same factors that actually cause this river capture: its volume, its resistance of rock, and its gradient. In this case, let's look at a cross profile or cross section of it. And if you look here, this river is represented here. And what actually happens with this river, as I like to use my pointer, this river is flowing over a relatively gentle gradient compared to this river. Can you see it? It's flowing over a steeper gradient. There is your watershed here, as represented here. And what actually happens, we already learned that when it's flowing over a steeper gradient, it will have more energy and therefore there will be more headward erosion. So this is the process that's happening here because of more headward erosion. And after capture, eventually what happens, because it has more erosive power, it's going to cut through the watershed. And look at what happens here now. Look at this water here is now captured by this stream. Okay, this water is captured by this stream and river capture has occurred. So basically, it's the same things that you are looking at in terms of capture, etc. Okay, the volume, in this case, it's now the gradient or resistance of rock. Okay. Now I know you look at this A, C, D, E, B. I left it here. Sometimes you could use the sheet as a bit of revision to identify them. The names are not given. But in my next slide, I will show you exactly what it is. So when this river, in this case, this river has captured. So one of the things that happened here is that this river most probably had something that's more than this. I cannot see volume or rather gradient here. I cannot look at rock resistance. But one thing I can see in this river is the volume. Okay. From there to there, it's a greater volume. So this river has captured here. Obviously, as I showed you in the other slide, all right, there'll be various adjustments to both rivers. Now, when I look at this piece has been captured due to the greater volume. The water is now flowing into this river. Okay? So this piece that has been captured becomes the captured stream. The stream responsible for capturing the water is known as the captor stream. Okay? And here, where the river gets captured or a part of the river gets captured, it forms like an elbow shape. I show you the elbow Can you see it in my hand? The elbow shape. Okay, so that then becomes known as the elbow of capture. Now, what happens? The headwaters have been captured. The amount of water flowing down will be less. All right. And eventually, this river will start drying out below the elbow of capture. You'll find even river gravel being found there. This area that has dried out is known as the wind gap. Okay. And then this river now has a smaller volume. You know, it reminds me of those adverts they have when somebody goes on a diet and they actually put on the same pants that they used when they weren't on a diet and they lost all this weight. That pants seems too big for them. In a similar way here, this river valley is quite huge because it's much bigger than this river because originally more water flowed. Now because the headwaters have been captured, it has a smaller amount flowing in a larger valley. So it looks as if it's a misfit stream. Okay, or it's known as a misfit stream, like the guy who's thinner in a large pants. Okay, I know that's a funny way of describing it, but these are the features that you would see in that. Okay, eventually, I got some explanations here. Captured river, captured stream is part of river that is diverted by the captor stream, taken away. Captor stream is the energetic stream that cuts back and intercepts the other river, the river that takes the water away. The misfit stream is the river that has lost its headwaters as a result of capture and it has less water. The elbow of capture is a point where of capture where the change of flow of direction occurs. And lastly, the wind gap is the area between the elbow of capture and the misfit stream, where the water stops flowing and the river gravels are deposited. Okay, so those are the features to identify and explain them. I love fooling around with my pictures sometimes. Okay, right. Now, let us go to the next slide, which is some questions taken from past year papers. Okay, now again, learners, as I've been telling you in class, look at the information. Various things. First of all, look at the heading, okay, of the resource. Now, it gives you a lot. Sometimes the heading tells you it's actually river capture. So if you don't, examiners give you a little hint. You understand? To say what the diagram is dealing with or what the resource is dealing with. And immediately, when you look at the word river capture, obviously, if you studied, everything comes to your mind. All right. One river intercepting the waters of another river. You understand? Elbow of capture. All these things come to mind. All right. Another thing you'll notice in the resources that letters, all right, stages, words have been put in like watershed, letters like A and B. What else am I noticing? It's quite interesting to do this. I look here, there's something there, A and B, the watershed. I go here, whoa, examiners added something. Can you see it? It's clouds with rain. An examiner has added it here and here. So why is these things added? Definitely it's going to be tested somewhere along the line. Okay, so resources have to make sense. They have to be relevant towards answering the questions. And it's so important to look at the resource and then answer the questions. So I see the same thing here. I look at what's happening. Whoa, river B is here. River B seems to be lengthening. Okay, it seems like a steeper gradient down here. Can you see it? It's flowing over a steeper gradient. This river is lower than this river. Okay, and it's flowing down a gradient. Whoa, I noticed what's happening here. Can you see it? Because it's flowing at a lower point over gradient, It's eroding headwards towards River A. So it's the captor stream. Eventually, what do I notice here? Whoa, it's now captured the headwaters of River A. Then I see the examiners put in a few more letters. C was, that's the elbow of capture. D, whoa, this area seems to be drying out. That's your wind gap. And A is your misfit stream. I've worked things out. And I promise you, learners, when you do it this way, you get most of the answers already. Okay? And it gives you a better understanding of the thing. It's easier to understand and easier to answer the questions. No papers sit, try to trick you. It's about applying your information. Once again, I'm emphasizing understanding the concept, learning to apply the concepts to different processes, and then applying it to past papers. If you do that properly, you're on your way to getting a good symbol. So let's look at the questions. Refer to sketch 1. Which river, A or B, is likely to be the captor stream? The one that captures. And if I go back to my sketch, I look at the two of them there. I need to go back here and I look at the two of them. The big boss, the captor guy or the river is B. Can you see it's capturing? So for the first one here, my answer should be B. This is the answer. And let me put it in a different color. The answer is B. Okay. Then I say name the climatic factor. And learners, you need to be careful about action words. Okay? When I say action words, name the climatic factor. Okay? If it's gradient, it cannot be a climatic factor. It has to be related to climate. That factor causing river B to erode faster. And when I go back to my sketch again, I see that's gradient, that's not a climatic factor. Now I realize that why did the examiner put that in? That is your rainfall, okay? And that's definitely a climatic factor. Okay, let's go to the next one. So my answer here would be rainfall. I hope I can write it. Okay, let me get my pen here. Okay, and I want to see if I can do it here. I love experimenting about all these things also. So I'll put in rain. And my writing is terrible. Rain fall. Whoa, I better not use this. I think you got the answer already. Do not write like this in an exam. Otherwise, we're going to have a problem. Okay, so let's go to the next one. I'm not going to put my writing here, but you can listen to me. What type of erosion caused the watershed to move towards River A? Now, there you've learned it already. All right. What caused this watershed to move? Can you see the watershed is moving towards River A? What has caused it to move? And immediately, you know, you will have studied the process. That is your headward or backward erosion. All right. Next one. Refer to sketch 3. Which one, River A or River B, is the captured stream? You already worked out that River A, B was the captured stream. So obviously, in this answer, you would easily do the one on that it's River A now is your captured stream because River B is the captor. Then it says, refer to sketch 4. Name the feature of river capture at C, and we go back to the resource. And when you look at C, you clearly see this elbow where the capture has occurred. So C would be your elbow of capture. elbow of capture. I'm not going to embarrass you with my writing. Okay, so C is the elbow of capture. I know you guys must be used to it on me writing on the Mindset Learning channel, so you know my writing is not very good. All right, then let's look at what feature D is. Feature D now. And let's go back to the sketch. And when I look at it, feature D is the wind gap. Can you see we basically worked out most of the answers by looking at the resource and studying it beforehand. And the more you practice, the quicker you will have or you will be able to do it in terms of analyzing the resource. And remember, you do have your reading time, etc. You can use all that to good value. Now, let's look at the next question. What is a term used to describe River A which has been reduced in volume? Examiner has given you a nice tip here. River A, reduced in volume. All right, reduced in volume. Let's look at River A again. River A now has been reduced in volume. And immediately you know that when the river now has less volume, the captured river, you understand, and the rest of the river that flows now has less volume, immediately that is your misfit stream. Okay, let's go on. Does river A or B flow at a lower altitude? That also we worked out while we're having our discussions. You can see that river B is flowing at a lower altitude and A is flowing at a higher altitude. And here we worked that out by looking at the word watershed, the high-lying area where river B is flowing lower than river A. So obviously your answer there would be river B. And let me put that in my green, use some colors, and put that as river B. Okay, that's flowing there. So lots of the answers, and this is your short questions. Lots of the answers come from the resource. It's about identifying, it's about learning to do things. And that is why when I told you in class, and I'm sure many other teachers and other subjects will say the same, analyze your resources properly. But in order to do that, again, I know I'm sounding like a broken CD nowadays. We can't say broken record. Broken CD is that I'm keep saying this all the time, the conceptual approach. Understand the concept, know how to apply it to processes, and then know how to apply it to questions. Okay, right. Let's look at this one. More or less the same, and I wanted to do that. You understand? To show you more or less the same sort of thing, but more in a sort of application, more explanation, descriptions, longer questions, which comes out for 15 or 16 marks. Okay. Again, the examiner has given you the clear tip. River capture. River capture. Okay. So we know what it's dealing with immediately. And then there's an important one here before captures. So capture has not occurred. Let's look at what's happening here. Okay. Now we can see there's river A at a lower altitude. All right. Steeper gradient here. We can see something happening here across the watershed. Okay. And then we can see something happening here. Headward erosion is happening. It's cutting in. Remember we said headward is cutting in towards the upper course of the river or towards the source of the river. It's cutting in. It's cut through the source now. It's cutting the watershed. It's moving away from the direction of flow. Yeah, you can see how it's flowing. And it's moving towards river B. Okay? River B. So that's river B. All right. And eventually, what are we noticing here? Again, that the river has cut through and captured this whole section or the headwaters of River A. So River B rather. River A is then the captor stream. This piece is the captured. We're already seeing again the elbow of capture, the wind gap, the misfit stream, all these features coming. But we're going to do it on a more full explanations now. So let's look at some of the questions that can come out. First one, define river capture. Remember, you give a full explanation. I know we always told you, and I always told you in class, to look at the marker location, but when it comes to a definition, it must be explained fully. Uh, and if you look at the recent papers, memos, etc., although it's a concept, a definition is a concept and can be explained in different ways as long as it means the same thing with using different words, it's fine. But it must be explained fully. And recently, you would have noticed in papers, short little definitions which are sort of vague are not given the mark. So something I want to say to you. So I'm putting it full here. When a more energetic river captures headwaters of a less energetic river. And I like it when it's full explanation because it gives you a better description, learners. All right. Now, let's look at the next question. What evidence in sketch A indicates that river capture is likely to take place? All right. Let's go back to the sketch. All right. And if we look at the first sketch here, or any of these sketches, we clearly can see, and the examiner has put it there. That is showing you clearly this river is eroding into the watershed. And by eroding into the watershed, headward erosion is happening. And with headward erosion happening, and if it continues to happen, it's going to capture the water. So my answer there is clearly the examiner has given me a good hint. It's headward erosion. Or some people, I would like you to write this. Headward erosion is taking place. Although we'll accept things like tributary of A is cutting back through the watershed, a description. But I want you to write that. Next thing it says, name two physical changes. And again, here the word is physical, not any other changes. And again, the action words become so important. All right? You can't give any other factor but the physical. Okay, changes that river A will undergo after capture. So let's go look at river A. Let's determine what it is. All right, we know river A is your captor. Okay, it's captured. Whoa, the writing goes off here, man. Captor, eh? All right, the captor stream. All right, not so bad as the other times. Okay, so this river will be gaining water. Okay, will be more energetic. Drainage basin will increase in size. All these factors will happen. That is physical. So let's look at the answer here. All right, we see again greater volume of water, erosive ability, which is physical. Drainage basin becomes larger, will be rejuvenated, meaning that it'll have more energy to erode downwards. Okay, more energetic, greater velocity. Can you see all these things are the physical changes that the river would do? But the most important thing there was to identify which one, whether it will be the captor or the captured stream. Then if it was a captured stream, it will be less volume of water, less erosive power, etc. So can you see how important your resources are in determining this? Okay, let's look at the next question. State two possible conditions. Becomes an important word now, learners? When it's possible, sometimes it is not found on the resource. So be careful for that word. Can you see it's so nice to use a highlighter? Not like how I'm using it where it's going up and down all the time. I'm sure your hands are more steady. Mine's is age. So possible tells you any factors that may not be visible on the resource but is geographically sound relating to the section that have led to river A being the captor stream. Examiners were very nice here. Eh? If you looked at question 164, it will give you a bit of an answer to 163. So we know it's a captor. We know that there's various factors. We know the factors of soft rock. We know the factors of greater volume of water, which could be result from higher rainfall. We know steeper gradient. Do we need to give, and if it's not on the sketch, will it be marked wrong? No, because we said possible factors. Now look, all those things, this marks here, you can just get if you read properly. Can you see it at a lower level? Softer rock, all right, higher rainfall, which results in greater volume of water. All right, steeper slope or gradient has greater erosive ability. I would like you to write these ones, all right? Because this, and although it's given, and you know, we examiners have to give various options, you understand? But I would like you to write these ones: lower level, softer rock, higher rainfall, softer rock, higher rainfall resulting to volume, steeper gradient, more than the others. Not that the others are wrong, but I would like you to write these ones first. Okay? And of course, higher volume is here. That's another one, which can result from higher stream order. You know what stream order, more streams found in the per unit area. So therefore, if there's more streams, which will have more order from more stream order fours and stream order threes, but I don't want to confuse you with that at the moment. That's under stream order. Okay, now let's look at one more question. All right, write a paragraph of approximately 8 lines, please. As I always tell you in class, I know some of you have writing that can be seen via remote sensing from space. It's big, so you'll use more lines. Some of you write very small and you use less lines. Approximately 8 lines is giving you a guideline, and it says describe how the reduced volume of water will negatively impact on farming in community B. Okay? Now, I know in class we've taught you and that this is a very gradual process. It takes millions of years to happen. So many of you will debate this issue that it may not impact so much, people will adjust, etc. Okay, but if a question like this comes out and you know that this is the captured stream, water will be reduced, and A is the captive stream, water will increase. You answer it that way, okay, if it ever has to pop up, okay, in that there'll be less water and more water. So answer the question like that. I know your point that you will, when I get back to class, you will raise the issue that this is a gradual process. As I taught you, it takes millions of years, but these questions can pop up. So let's answer it that way. So we know river B, which has been captured, therefore a reduced volume of water, therefore they'll have less water, and of course it will negatively impact with less water, especially on farming. Okay, so let's look at it. It's specific here: reduced volume of water, negative impact on farming. There's specific facts which you have to focus on. Can you see the answers? Less water for irrigation of crops. Okay, right. Do I say reduced yields? There will be reduced yields and leave it at that? No. Remember in class, I've always said, it says here, describe how. So we have to put in something related to the water, like this, reduced yields due to lack of water. Can you see how we're answering the how factor? All right, that why is it happening? All right, increase costs to obtain sufficient water. Can you see how it's related? Increase costs to obtain sufficient water. All right, if there's less water, there'll be reduced flooding, which reduces natural fertilization of soil. Because when floods happen, rivers, etc., overflows, sediments get deposited, you like in the floodplains, which makes the soil more fertile. Okay, input costs from there. You understand? Okay, when we talk about this increased costs here, will increase cost to farming increases because now they have to obtain sufficient water. I would have loved to put the input costs, okay, to farm increases as they have to buy more or get more sources of sufficient water. Farming no more economically viable, and it goes on. These answers are self-explanatory. Loss of jobs because now the farming declines. Loss of incomes because the yields decrease. Lack of water. Poverty increases due to lack of crops to sell. Can you see? All the answers have a reason. Rural urban migration sets in, maybe it doesn't have any interesting. We could add here due to lack of jobs, lack of domestic water, okay, for the farming community. I'd like to add that on. All right. Lack of recreational facilities. The examiners have been nice to give us that one. Okay. We could say if we change this and said lack of recreational facilities for the farming community, then it becomes full answer because the question said negatively impact on the farming community. So if I just said recreational facilities, then as I said in the beginning, all right, it may not be, but for the farming community, all right, poverty increases due to the lack of access to food. Okay, that also because it water lack of water supply, and because of a lack of water supply, we find that uh, there's lack of food, and of course, it result in food insecurity. Poverty increases because lack of jobs. There's various ways of explaining it. Another thing that we could pick up here that I keep adding on to is the fact that this, when you look at these memos here, they are marking memos. So sometimes they're not as detailed because a marker needs to look at it quickly. But as I explained to you, we need to put in, I would like you to put in more, lack of recreational facilities for the farming community. If you just wrote recreational facilities, doesn't make sense. All right? Lack of domestic water for the farming community. I'm not saying that won't be marked correct, but let's put it as a full answer. You know, in class, I always say full answers relating to the question, which is the farming community. Let's not take a chance which puts that marker and says, should I or shouldn't I? You put your full answers so the marker says, this is 2 marks, definitely. Okay, learners. So did something on river capture and abstraction. This was one of the areas of concerns that you have mentioned. All right. If there are any other areas, you will let me know, and I will do further programs on that. I wish you again all the best and stay safe. Once again, I'm pointing my finger, and let me enlarge in that so that you know what I'm doing. All right? And I'm pointing my finger. Obey the rules of the lockdown. It's there to benefit you. It's there to keep you safe. I know things get tough. I know I've been at home all the time and it's not easy, but it's the best thing to do. Keep well, learners. All the best till our next program.